All right, let's talk about something that drives every single developer crazy. We're going on a journey into the developer's labyrinth, that maddening place where you're hunting for a bug that has absolutely nothing to do with your code. Let's get into it.
So, I want you to think about this for a sec. What's your most hated bug? You know, the one that makes you want to throw your keyboard across the room. Maybe it's some nasty race condition or a classic off by one. We've all got our personal demons, right? But I bet there's one type of bug that we can all agree is just the absolute worst.
Yeah, it's that one. The one where your code is perfect. I mean, you've stared at it for hours, right? You run the debugger line by line. You're 100% sure the logic is flawless. And it still blows up. And this quote, this just nails it, doesn't it? It perfectly captures what this labyrinth is all about. You're not just fighting your own code anymore. No, you're fighting the entire execution environment. The OS, the shell, some random library, it's all suspect. That's the rabbit hole we're going down in this explainer.
So, our story starts with something that should have been, super simple. Just launch a background daemon. Easy, right? Well, what started as a simple quest turned into this whole ordeal, a hunt for these invisible system-level ghosts.
So here's ghost number one. You type AI agent start, and boom, it tells you start is an unexpected argument. What? How is that possible? Well, it turns out it's not a bug in your code at all. It's a known documented quirk in the typer library itself. If your app only has one command, typer just doesn't expect a subcommand like start. The fix? Kind of wild. You have to add a second, hidden dummy command just to trick the library into working the way you'd expect. And this is where we get our first big takeaway, our first codified principle. The answer was out there the whole time, buried in some documentation. The lesson is huge. Trust the pattern. If your problem looks exactly like a known issue you find online, it probably is that known issue. Don't waste hours rediagnosing it. Just apply the fix. This is the first landmark on the map we're creating to navigate this labyrinth. Okay, progress. The daemon is finally running. So you think, let me just run a quick curl command to test it. And then it fails. But with weird PowerShell errors. Why? Because on Windows, when you type curl in PowerShell, you're not actually running curl. You're running something called Invoke-WebRequest. The shell was literally tricking us. You know, this teaches us a really important lesson for any kind of cross-platform work, and it's our second principle. Just abandon unreliable shells. Seriously, for anything critical, stop trying to fight the inconsistencies. Just write a simple Python script with the request library. It completely sidesteps the problem and works the same way everywhere. Problem solved. Okay, we're so close I can taste it. The daemon is up, we can hit it with our new Python script, and we get a 500 internal server error. The logs are all screaming about missing API keys. But wait, you exported those keys in your terminal. So what's going on? Well, it turns out the background process wasn't inheriting any of the environment variables from the shell that launched it. It was like it was born in a total vacuum, completely clueless about those keys. And that brings us to our third hard-won principle. Daemons require explicit environments. You just can't assume a background process is going to magically know about its parent's world. Never. The right way to do it, the standard way, is to make the daemon load its own environment, usually from a .env file. That way, it's totally self-contained. Another point on our map. So, finally, after wrestling with all those ghosts, the daemon is stable. We're done, right? Not even close. Because just when you think you're out of the labyrinth, you find out it has a basement. And that's where the next set of problems live, when our own automation starts creating its own ghosts. We're now entering what the source material calls the automation's echo chamber. This is such a great way to put it. It's that place where all our smart, sophisticated tools, the ones meant to make our lives easier, start bumping into each other in weird ways. They create these strange feedback loops that can take a tiny, almost invisible bug and amplify it until it brings the whole system crashing down. First up in the chamber is a ghost that I bet a lot of you Python devs have seen before. Module not found, no module named SRC. Your first instinct is to mess with Python path, right? But that's not it. This is actually a deep-down misunderstanding of Python packaging. Here's the deal. In your PyProject TOML, when you define a script's entry point, you should never write src.something. Why? Because once the package is installed, that src directory basically disappears and becomes the root of the package. It's a subtle but critical detail. Okay, this next one is super sneaky. A script just crashes. The error, a Unicode encode error. And the culprit, an emoji.
Now, your code is perfectly fine with emojis, but the automated workflow was running inside an old legacy Windows console, and that console has no idea what to do with the Unicode emoji. It's like the environment itself reached out and strangled the application just for trying to be friendly.
And this gives us another really practical principle for our map. When it comes to automation, reliability is king. Yeah, emojis and fancy characters are cool for interactive stuff, but in your automated logs and output, they're just a liability. Stick to plain old ASCII. It might be boring, but it's guaranteed to work everywhere, on any system, no matter how old. It's about building for resilience. All right, now we get to the final boss of this level, the most infuriating bug of all. A workflow starts, and then nothing. It just hangs. Forever. There's no error message, no log entry, no timeout. It's just gone. A digital ghost. These are the absolute worst bugs to debug.
So what was it? A nested interactive deadlock. Check this out. You have a main process, right? And it's not interactive. It's just a script. That script calls a second process, and that second process calls a third process, say something with Git, that needs to ask you a question like, are you sure? But here's the problem. The main process at the top of the chain never had access to the keyboard in the first place, so it can't pass that control down. The result? The grandchild is waiting for an answer it can never get, and the whole thing is frozen. Total deadlock. And the fix, once you see the problem, is actually pretty simple. It's like a secret password. You just have to tell the main workflow runner, hey, this specific step might need to talk to a human. By marking that step as interactive true, you're telling it to pass the keyboard all the way down the chain. It's a simple flag that prevents this entire category of silent failures. All right, our last ghost for today. It's a script that works perfectly the first time, but if you dare run it a second time, it crashes. In this case, it was a script using git commit-amend. The second time it ran, Git said, hey, there's nothing new to amend, and it threw an error, which is correct. The problem wasn't Git, it was the script. It wasn't idempotent, a fancy word for safe to run over and over. A good script should handle that nothing-to-do case gracefully. And this brings us to our sixth principle, which is really about using the right tool for the job. As soon as your automation logic gets more complicated than do this, then do that, like say commit only if there are changes, it's time to drop the shell script. They're just too brittle for that kind of logic. A quick one-liner in Python is way more robust, it's easier to debug, and you know it's going to work the same everywhere. So we've made it through the labyrinth. We've fought all these ghosts, and we fixed the bugs. But what's the real prize here? It's not just that the code works now. No, the most valuable thing you bring back from a journey like this, it isn't the fix, it's the map. And this is it. This is our map, forged in frustration. Every single one of these principles is a shortcut. It's a warning sign. It's a way to save the next person on your team from falling into the same traps and wasting hours or even days of their life. Our source material has a fantastic name for this map, the tribal log. And this is the real heart of the whole explainer. It's not just about writing stuff down. It's about building a culture. It's a habit of taking these agonizing debugging sessions and transforming them into collective knowledge, a permanent shared asset that makes the whole team stronger. This is how you ensure that nobody ever has to go through that same specific hell ever again. So, I'm going to leave you with a question to think about. What was the last bug that made your team want to pull its hair out? And then ask yourself this. Is all that hard-won knowledge you gained, is it written down in your own tribal log? Or is it just trapped in someone's head, waiting for the labyrinth to claim another victim?